All right, everybody, I think we're going to go ahead and get started. It's a quarter till, and I tend to ramble. So probably need all the time I have and twice that. My name's Andrew Kutz, and I work for VMware. And in case you are not where you think you should be, this is a talk on adding support for new platforms such as AWS, vSphere, GCE to CNCF's CrossCloud dashboard. And with that, we'll go ahead and get started. So this is our agenda for today. It's pretty straightforward. Don't have a lot of time to add the humor I normally would. That's okay. You're probably saved from that. So first of all, what is the CNCF CrossCloud CI? I'm going to assume you all know what the CNCF is and just move past that. The CNCF CrossCloud CI ultimately culminates in something like this dashboard. They have a project called CrossCloud that builds Kubernetes and provisions it to multiple platforms, again, such as GCE, AWS, Packet, vSphere. And then it builds and deploys multiple CNCF projects. And you can see on there some of those, Linkerd, Fluentd, Core DNS. And it ensures that different versions of Kubernetes, it always builds the last GA release and then head, can coexist harmoniously with several well-known CNCF projects. It doesn't run the Kubernetes E2E conformance tests, but it does run some tests for the projects you see up there. CrossCloud is really three distinct components: build, CrossCloud, and cross-project. Today we're going to be focusing on the CrossCloud component. And it's what enables the multi-platform support. And that is a pretty up-to-date view of what platforms it currently supports. In case you can't see it, it's AWS, Microsoft Azure, GCE, IBM Cloud, Packet, OpenStack, VMware vSphere, and OCI, or Oracle Cloud Infrastructure. And today's talk is to how to help you put your platform on the dashboard. The CrossCloud project actually leverages Terraform, and we'll get into that in a bit. But when you want to add support for a new platform, you have to basically either create or leverage an existing Terraform provider for your platform. Directories at the root of the project map to those platforms. Again, same list I've been repeating. And the other directories are Terraform modules that the platform projects then import. So modules for doing things like deploying DNS, deploying Kubernetes, creating your kubeconfig file, what so on. So how do we actually add support for a new project? Well, it's easy as, like I say, 1, 2, 3, and -1. Several steps. But it's pretty straightforward. There are some hiccups along the way, and hopefully this talk will help you handle those with the aplomb that I did not. So before you begin, what are the requirements? Is there a Terraform provider for your platform? Luckily, when I began work on this, and myself and Hui, who is here today, I'm the one on the stage, but honestly, he did most of the work. And if I can get that arrangement for all my projects going forward, then well, it'll be boring, but at least I can put the blame on him. So is there a provider? If there's not, you will need to create one. That's not in the scope of this talk, but there is a link from the presentation that takes you to the list of Terraform providers, and you can see if there is a provider for your platform. You'd be surprised, there are providers for dozens and dozens. Is Docker installed locally is the next requirement. Why do you need Docker locally? To do testing, to test that your changes are working, and we're going to use that in a bit to actually deploy Kubernetes with the CrossCloud provisioner from my laptop to a public vSphere instance. And finally, it's not required, but it would be really good to have an IDE that has support for Terraform's syntax, so that when you look at a file, it's just not black and white. And it's HCL, it's HashiCorp language. But yeah, it's easy to read, but the syntax highlighting is not as nice. And finally, if you've not used Terraform before, there is going to be a learning curve. It was new to me. I'd use Vagrant, but Vagrant's files are based on Ruby, Terraform is not. It is all declarative, which people love and hate. I'm somewhere in the middle. But the nice thing that it does do for you is it handles ordering. All resources defined in a Terraform file can depend on other resources. So it handles the ordering that things have to come online for you. Without that experience, there could be a slight learning curve, but again, I was brand new to it as well, and we went from not being on the dashboard to being on the dashboard in about a month and a half, completely net new to it. I was also brand new to Kubernetes this year, so I don't know why they let me come up and give a talk, but if nothing else, you all look way more capable than me, and I was brand new to Kubernetes in April. So, not new to CI, so if you're new to both, maybe there'll be a bit more of a learning curve. So the first step to creating a new platform, adding support for a new platform, is forking the CrossCloud project on GitHub. I'm not going to demonstrate that because I've already forked it, but I think we all know how to fork projects on GitHub. Actually, I don't have, let me show you that project, because it just now occurs to me that I don't have it up. So this is the CrossCloud project on GitHub. There is actually a link to this in the presentation. It's just CrossCloud and then cross-cloud. And again, there's a link, but I just wanted to show you what it looks like in GitHub. So you fork that. I always find it helpful to go ahead and add a Git Remote as upstream. So when I clone my fork, I immediately do a Git Remote add upstream. So if I ever need to fetch changes, that's something you can do for all of your projects. So this next step, this actually used to be a lot more difficult. Very recently, we created a small tool that can help you create a skeleton for adding a new provider, and I'll demonstrate that here in a moment. The skeleton includes initial documentation, like the README, bare bones Terraform files, as well as some helper scripts and a hack directory to make standing up, tearing down clusters a little easier. So we can actually show that off right here. I'm just going to copy this as is. So we're just going to, well, let's actually prove that KubeCon doesn't exist. It does not. Hey, it's created. So it kind of tells you the steps that you need to do next. Now, this tool relies on some markers in two files, a Docker file and the provision script that aren't merged yet into master. If that was the case, since they're not yet merged, it still can work without it. If we do this, you're going to get additional information that you need to update those two files manually. So again, I just added some markers that lets me find the last. Can I zoom it? Yeah, sure. Is that better? All right. Yeah. We're going to go through these steps one by one, but I'm going to go ahead and go back to the other branch. Okay. So let me rerun that, and then we can look at the scripts that it creates. Okay. So there's my KubeCon directory. So the very first thing it creates is it just creates this README. And again, if you go to the actual website, it's going to look very much like VMware's because I just copied ours. So running that file gets you a README, which starts you on your path to creating the new provider. You still need to fill in things like the configuration, but it does give you the commands to stand up the cluster once you have it up. But beyond the README, there are a few key files you need to worry about. And let me switch back to the presentation, and then I don't know what I just did there. Right. So the very first step would be configuring your Terraform provider. And that is going to be in the providers file. So there's obviously not a KubeCon provider. Hold on. Is that better? There's obviously not a KubeCon provider, but if it was something like AWS or vSphere, I can show you vSphere's provider. So for example, this just ensures that the version is equal or greater to the specific version of the provider, and it configures it with its credentials and allows unverified SSL, what have you. But so you would need to configure your version of that, and I thought I put a link to the list of providers. It's actually a fine time to just go ahead and show that. Terraform providers. So here's a list of all the Terraform providers. And again, there are a ton. And these are just, I think, the major cloud providers. So if you don't have one, it has instructions on how to create it. But it also has instructions on how to configure yours. Okay, next step. After you've got that configured, you might have noticed that there are certain things using these, what they look like variables, right? They have the $ and the var dot. What are they? Well, they are variables. They actually reference Terraform input variables, and they are defined in this file called input.tf. And these are all of the configuration properties that your project can use. For example, like the name of the cluster, the directory inside the container where the data is stored. And then beyond that is just common data. These are actually, that's not even true. This is the only piece of information even specific to this project. The rest of this is just common data that is true for all of the platform providers. Now, why do we define them here and not at the root of the CrossCloud project? As I said, every platform directory is a Terraform project. There were two ways that the CNCF could have built this, and they chose B instead of A. Both are valid. Version A would have meant that the root of the CrossCloud project was a Terraform project, and they loaded the platform directories as Terraform modules. Instead, they run Terraform inside of the platform directories and then load all the other directories that install Kubernetes, create the kube config, all that as modules. Because of that, your directory controls the input for the project. And because some of those other modules have expected inputs themselves, you have to define them at the root of your project, because any one of these at the root of your project can then be set via a configuration file, but also via the command line. So tf-var name equals any configuration parameter, any variable defined in input.tf can be defined as an environment variable by prefixing tf-var underscore and then just the name of it. So that allows you to define that at runtime. You notice that they haven't ever, the CNCF hasn't actually updated the version of Kubernetes since 1.10, not in the repo, but they do when they actually run, when they actually provision it. So you want to make sure all of your input parameters that you need are defined there. The file modules TF, this is where it starts to get interesting. This is responsible for loading your project's modules as well as the common modules. The scaffolding that the script creates includes 3 modules. The module for the control plane nodes, which is referred to as master due to just the way it's referred to in other projects. The module called worker for the worker nodes. And finally, the module load balancer. I added that module even though not all providers use it. And if you don't use it, that's fine. It's configured by default to just return the IP addresses of the control plane nodes. But if you want to, it gives you a placeholder to add a load balancer. The other modules that this file loads are the modules responsible for configuring the common components. So master templates, you can see it loads it from source./master templates 1.10. This is what loads or deploys Kubernetes and all of its dependencies to the master node or the control plane nodes. Module worker templates is responsible for the worker nodes. And then load balancer loads our load balancer. DNS deploys DNS. TLS, this generates all of the certificates that are necessary to deploy Kubernetes. And finally, kubeconfig just generates a kubeconfig locally so that you can access the remote system. I kind of need to get moving here. Yep. So right now, the CrossCloud project does expect your platform to have a valid cloud provider. I have a branch out there for which I don't think yet I've opened a PR, but I've updated their templates to give you the ability to not need the cloud provider. You can't just give it an empty input because the name of the cloud provider is also used by them for other things. It just adds a Boolean disabled that defaults to false. But right now, it does expect you to have a cloud provider, and the scaffolding just creates a template file that loads this thing called cloud.conf, and then it interpolates the variables in there with these input values from input.tf. Where is that used? Well, you can see it's template file cloud.conf. When the module gets loaded, cloud config, it loads it in here. It looks up the template data, and it just interpolates that data with the input variables that you provided it. The modules that we create, again, are the master and worker nodes, and so they've got very similar files. You've got your input file, the number of nodes you want, the name, the cloud init data, the number of CPUs, amount of memory in megs. That's your input, but you can also have output. Both the control plane nodes and worker nodes output the IP addresses of the machines they create. And that is because in the parent project, the root of our project here, you will see where is it? Oh, it's going to be at the load balancer, I think. Load balancer. See, module.master master IPs. That maps back to this. It's module.master master IPs. So the modules can share information with each other via outputs. And finally, we've got, in the control plane and worker modules, we actually then define the resources that get created. And again, this type of resource is going to be specific to your Terraform provider. So the scaffolding can't assume what it is. It does some basic configuration. Count is a Terraform specific property. And so, for example, by default, the CrossCloud project creates 3 control plane nodes. So there will actually be 3 machine resources. And those can actually be referenced using either the elements property like here or just normal array indexing. In fact, you can see what this does when it outputs the master IP addresses. That star says, I want the, basically it joins this array, and this array is a list of the IP addresses from each machine's, machine node's default IP address value. And again, the load balancer is the scaffolding that it creates. This load balancer, the scaffolding creates is very dumb. It just says, give me a list of the target IPs, and it just outputs the first value from that list. There actually are more concrete implementations of it. This is vSpheres. It actually leverages AWS for the load balancer. So it can be as complex or as simple as you want it, but the scaffolding doesn't make any assumptions, and it just creates something that's pretty dumb. And that's pretty much everything that, finally, the scaffolding does create some helpful commands here. Deploy.sh. And basically, you could just run hack/deploy.sh and give it the name of a cluster to deploy, and then as well as destroy.sh. And that just calls this. And you'll see an example in a minute where we're actually invoke something very similar to that. It's just, I use those files or versions of those files whenever I'm doing testing. That way I don't have to type out the whole Docker run command every single time. And those are referenced in the README as well. Yeah. Let's go ahead and see. Oh, the last two files that you have to update. The scaffolding did, or the script did update those because it has like I said, it has markers. So if you ran that script on a version of the CrossCloud project that didn't have these markers, you would need to remember to add that copy KubeCon/CNCF/KubeCon. It's what copies the assets from this project into the container image. And then finally, you would need to make sure that you add this at the end of the provision.sh. It is the entry point for that image, and it's what's responsible for running Terraform. You can see it has two commands, deploy and destroy. When they run it live, they use an S3 backend to maintain state. When you run it locally, you often will just use file. So let's go ahead and see what that actually looks like. So the very first thing we would do if we created a new provider is that we would rebuild the container image. Mine's already built, so I'm not going to rebuild it. But let's go ahead and, I thought I updated that. I did, it is not wanting to respond. Okay, sorry about that. I'm offline, of course I am. One moment, I'm sorry. It's okay, I actually spent part of this morning recording a demo of this very step because I knew it would fail right here. Let me try switching to the other network. I apologize for this. You know, the wireless worked great on Monday before everybody arrived. And then the show floor opened. All right. So yeah, we'd want to rebuild the Docker image. And actually, we can go ahead and give a quick demo of that. What I'm going to do, though, is I'm going to remove those. Remove KubeCon. Docker build, T. And that's just going to rebuild this image called provisioning. And that's the name they use for the image locally as well. So we just kind of stuck with that same convention. Technically, there's no reason it couldn't be pushed to a registry, but when you're doing development, you're not going to be using the public one anyway. So it updated the image, and we're going to deploy a new Kubernetes cluster. Now, this is just an example of what you would do. You do the Docker run, make sure the image is removed, or the container is removed after it quits. You want to make sure you do the at least -t, which allocates a pseudo terminal. And if you don't do that, you won't be able to control C out of the command because it won't send that control code through, which is bad. I'm going to explain some of this when we get to the common problems because this is specifically there to solve one of them. Let's just go ahead and do the demo. Let me grab my, had it cached, I thought. Yeah, there we go. Now, did I remember, the question is, did I remember to actually, I'm going to go ahead and do that just in case I didn't. Did I remember to tear it down before I came in here? Otherwise, we just waste a few minutes. All right, so again, I'm doing the Docker run with the provisioning image. These DNS servers are important. I'll tell you why in a minute. We're mapping the data directory in the folder I'm currently in to CNCF/CNCF data. They use that directory in their image to store the Terraform data. This isn't necessarily required. This just maps the .terraform directory in the working directory from the container back to the current directory's .terraform directory. Why is that nice? Because the first time you run this, it's going to have to download a bunch of Terraform plugins, which can take a while. And if you map it back to your local directory, you don't have to download them again. These -e flags are passing environment variables in to configure certain things. These are the ones specific to CrossCloud. These up here are specific to our provider. Cloud tells it the type of platform to which it's deploying. Backend, remember I mentioned they use S3. File's also a valid candidate. Name, we're going to deploy a cluster called KubeCon. And finally, the command to execute, deploy. The other option is destroy. So let's go ahead and execute this and hope it works. And again, if it doesn't, I've got a video of it working. I kind of hope it does because I want to be able to show it off in the actual vCenter environment. So what's actually going on here is it is creating certificates for all of the Kubernetes services, including like the provision service account certificates. It needs a CA for that, right? What is that giant blob you see? Anyone take a guess? Text? Yeah, it's text. It's a base64 encoded version of the CloudNet data, user data. So the way that they deploy this is through CloudNet. In fact, while this is doing this, we can actually look at that. They use CloudNet to deploy against everything. So you can see these different versions. What's the difference between 1.10 and the same one Ubuntu? If we look here, this is non-Ubuntu. It expects it to be CoreOS. This is just a CloudNet template. And the Ubuntu version, it's called Ubuntu, but it's not specific to Ubuntu. CloudNet, even though it was created by Canonical, became very popular with CoreOS. And so, you'll often see CloudNet files with this at the top of it, but that's specific to CoreOS. And so they've got one that works without CoreOS as well. The longest step here, at least for us, is this one right here, creating the AWS Load Balancer. I tried to figure it out because I could create a load balancer in about 2 seconds. But if you go look at the source code, they actually will not move past this until the load balancer's listeners are responding. But that blocks everything else. So it takes a bit before this, it takes about 2 minutes usually before it decides just move on. Because the listeners can't respond until those machines are up. Let's see my time here. Okay. Yeah. Any questions so far? I've got a section at the end dedicated to that, but I want to go ahead and ask since we're just waiting at this point. While it's doing that, I actually will do the resolving common issues. So remember I kept saying, hey, notice these DNS entries. CrossCloud uses a shared DNS server. When it's standing up the environment, one of the things that it does, and in fact we can see that if I had thought to do it, although it actually doesn't have, yeah, here it is. It's creating these DNS entries in their shared DNS server. You can see it right there. And that's basically making it easy for them internally to the Kubernetes cluster to reference the nodes without needing to necessarily know the IP addresses ahead of time. The nodes are just responsible for, or Terraform is responsible for entering that data into the shared DNS server. If you run the provisioning container without that DNS whatever it is, 147.756.923, you're not going to know how to access your cluster. Because the kubectl the kube config they write out has the DNS name, has the FQDN. It doesn't have the IP address. So your operating environment needs to be able to resolve names against their DNS server. And you can add it to your host, or you can just do Docker run and include the DNS there. Somebody helpfully created a kubectl wrapper at the root of the project that does a Docker run and adds this DNS server. So we'll see that in a moment. So right now, it's just waiting for the cluster to come online. Hopefully it will. Yep. So it actually brings it up in about 3 minutes, and then it's adding a bunch of manifests to ensure that everything's there and happy. Now it's going to wait for the nodes to show up. So what's the next common issue that we see? Yeah, the cross-cloud image should be built from the root of the project, or give it a .. if you're building it from the platform. I already mentioned, make sure you add the -t flag, or else you can't cancel out of a deployment. And here's one that we had to figure out the hard way. Even though you can immediately add entries to the shared DNS server, until the CNCF team whitelists your domain, that cloud name, their Sky DNS server won't respond to queries for your domain. So you need to make sure they add that, and they will add that, super quick. All right, so it's online, and we can verify that real quick by just using our helpful wrapper here and say git all. Yeah. See how many nodes it has. It's got one node. And then see what pods it's got in the kube system namespace. It should have like the kube DNS, kube proxy, heapster. And what does that actually look like over in vSphere? Well, it deployed 3 control plane nodes and 1 worker node. Now, why 1 worker to 3 control plane nodes? Not positive. But that's their default configuration, although you can modify that as you wish to do. And then the load balancer it creates is over here in AWS. Now, you may not use the AWS load balancer. You may use one of your own, or you may not use one at all. Doesn't really matter. Yeah, here we go. That's the load balancer from, a few moments ago. So let me get back to the presentation. And then finally, just destroying it. It's pretty easy. You just run, in fact, we'll just use the helper command now. And remember, it's here. Make sure, did I update that? Yeah. Remember, the scaffolding will create the same helper commands that I'm using here for you. So that whole Docker command we used to deploy it, you could have just done /deploy.sh KubeCon. It'd be a lot easier to remember that than have to type out everything. But it's good to know how it works from the bottom up before you start using the shortcuts. So while it's destroying the cluster, and by the way, it destroys all the resources associated with it as well. The load balancer, the TLS certificates, the kube config, the machines. While the cluster is being destroyed, I kind of want to open it up to questions or feedback. Does anyone have any questions about something I didn't cover, maybe something I missed, or that I should have spent a little extra time on? Does anyone feel like they could go back and create one of these? And if not, like what would be blocking you from doing that? Yeah, okay, well, let me see what we're doing. It's still destroying. Again, that load balancer is what takes forever. So, all right, so it looks like it should be destroyed. Let's verify that it's gone. Yep, we don't see KubeCon there anymore. And that load balancer usually takes a moment to go away. Yep, it's gone. So that was it. And again, just using the scaffolding command that is up here should get you started to creating one of your own, adding support for your platform pretty quickly. And if you have any questions about how to do that, or just want to suggest some ideas that could make this even easier or smoother, please feel free to contact me or my colleague, Hui. And like I said, the link to the CrossCloud repository is in the presentation. Probably should have been sooner. And if you actually want to see the working version of one of these are all the pull requests for the VMware platform provider. How am I on time? Oh, man. I think that went pretty well in terms of time. I hadn't got a chance to practice the whole thing like I wanted. So if there are no other questions, you can have back the rest of your day. Thank you.